Standing by for confirmation of LOX load complete on stage 2.
Stage 2 LOX load is complete.
Right on schedule. So the next major milestone that we're listening for is at about T-minus 60 seconds when Falcon 9 will be in startup mode. That means that the Falcon 9 autonomous internal flight compute closeouts are on their way there for Falcon 9. And we are just about 15 seconds away from startup mode, when those autonomous internal flight computers will take over the launch countdown. Then just inside of T-minus 2 seconds, we will light the M1D engines for liftoff.
Falcon 9 is in startup.
There's confirmation that Falcon 9 is in startup mode, and at this time the NRO payload continues to be healthy, and our Falcon 9 team is tracking no issues on the rocket.
LD is go for launch.
There's confirmation from our launch director that we are go for launch this evening. So let's sit back and watch as Falcon 9 lifts off from Vandenberg Space Force Base in California.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and lift off of Falcon 9. Go NROL-113. Vehicle is pitching downrange. Stage 1 propulsion is nominal.
If you're just joining us, Falcon 9 has successfully lifted off from Space Launch Complex 4 East, as you can hear on your screen, and we are getting some awesome shots of ascent. We've also heard a few call-outs so far from Mission Control.
Nominal power and telemetry.
Including that everything is looking nominal from both a power and telemetry standpoint. Now, in just a few moments, we're going to throttle down the engines in preparation for max Q. And with that call-out, we hear that Falcon 9 is moving faster than the speed of sound.
Max Q.
There's that max Q call out. As you may have heard us mention before, max Q is a critical flight milestone because this is the moment in flight with the highest amount of aerodynamic pressure. So with that, we have 3 events coming up in quick succession here, starting with MECO, Stage SEP, and SES-1. Main engine cutoff, or MECO for short, is where all 9 M1D engines will shut off to slow the vehicle down in preparation for stage separation.
MVAC chill.
There's confirmation that we're chilling the MVAC engine for SES-1. Stage 2, of course, will continue to second engine start 1 after stage SEP. And that's when the single MVAC engine will ignite to propel the second stage to orbit. Less than a minute after all of these flight events, the fairing halves will also separate and jettison away from the rocket. We'll hear that one called out from Mission Control, but as a reminder, we won't have any payload views tonight at the request of our customer. Standing by for main engine cutoff in just about 15 seconds.
Main engine cut off. Stage separation confirmed. MVAC ignition.
We have had great confirmation and views there of main engine cutoff, stage separation, and of course second engine start 1. We are standing by now for the call out for fairing separation. And we will be attempting to retrieve these fairing halves once they fall back down to Earth using our recovery ship, Go Beyond.
Fairing separation confirmed.
There's confirmation of fairing sep. Now, coming up about 3 minutes from now, the booster, which you've got great views of the grid fins on your screen right now, will initiate its entry burn to begin its journey to the Of Course I Still Love You drone ship, which is currently stationed in the Pacific Ocean. Those grid fins on board Stage 1 are the primary mechanical structure that we use to guide the rocket on its way back to Earth. Of course, what we are leading up to is the entry burn, expected again at just about T+6 minutes after liftoff. If you are just joining us today, you're coming into our live webcast of the NRO payload launch. We had an on-time 8:20 p.m. Pacific liftoff from Vandenberg Space Force Base in California, followed by successful main engine cutoff, stage separation, second engine start 1, and fairing separation. To start the entry burn, we'll relight 3 of the M1D engines on board the first stage, which is essentially the same as pumping the brakes. We need to slow the vehicle down as it passes back into the Earth's atmosphere to reduce re-entry forces, which helps us to recover and reuse the booster on future flights. During the entry